Welcome and thanks for joining us. My guests today are Hillary Hunter. She is the Vice President and Chief Technology Officer for IBM Cloud. And we have Stephanie Chiras. She's the Senior Vice President and General Manager at Red Hat Enterprise Linux. Good to have you both with us today. Our topic is Cloud of the Future. And I guess cloud is always in the future in some sense for the federal government because the use cases and the cloud technologies keep advancing. But as DoD in all of its manifestations, fourth estate, the armed services move toward this next generation of cloud adoption, what do you see it looking like? What's your vision for the cloud of the future? Hillary?
I think the cloud of the future is such a broad but such a timely topic. We see in the commercial space that the current environment is only accelerating adoption of cloud, and cloud very much has become a cloud of now conversation. But from the perspective of something like the DoD, of course, it's really important to do long range planning and have a 5 and 10 year vision for where things need to go. I think that a couple of key principles that we see include, number one, cloud of the future and the cloud of now both need to be grounded in open source and open principles, and I'll let Stephanie elaborate more on that. But open source, open principles, community contribution, ensuring collectively that things are secure and monitorable, et cetera, is so important for this space. I think secondly, use of core technologies that ensure the highest possible levels of data protection, even when working in a shared environment like cloud, is another core value that we see as being really important to the DoD and to, in general, kind of federal computing conversations. For us, that mirrors something that we're seeing in enterprises and in the commercial space, especially like in financial services. They are deeply concerned about stewarding their data, as is the DoD, deeply concerned about stewarding their data. So when we talk about cloud, the concept of data privacy, data protection, cryptography, and things like that, we think all of that is and can be today, but moving forward, central to a robust cloud conversation. And I think, lastly, I would just introduce the term confidence. I think there needs to be confidence in planning for the cloud of the future. And that includes making the cloud robust against the things that will come in the future. Quantum computing, even as an example, is something that, we work with people to be able to prototype future quantum algorithms using quantum hardware attached to the cloud, et cetera. But we also work with researchers that are developing algorithms which we deploy in the cloud that are safe against future quantum computers that might be able to crack cryptography. And so in that forward-looking cloud of the future category, there's the word confidence is first and foremost in my mind, but confidence has clear technical grounding around core technologies that mean that we are planning out even for when quantum computing may be sufficient to introduce some new considerations on how crypto and stuff are done. So those are sort of the three categories that come to my mind, but certainly Stephanie would have, I think, a lot more to say about the first one that I mentioned about open being a key part of future cloud strategy.
Stephanie.
Thanks. So maybe, and Hillary did a great job of, the cloud of the future is going to depend on the choices you make today. And I think that's what we keep hearing from customers. What are the choices I can make today to prepare so that I have the choice to use the cloud of the future that I will need tomorrow? Because the one thing that is clear is that innovation is not slowing down, right? It's going to continue to accelerate and accelerate into things like quantum and new types of applications. And nothing is a full switch, right? We still have traditional workloads that are still being deployed. How do I do that when I also want to consume all the latest innovations coming? And for us at Red Hat, we fully believe in open source and having that be that grounding foundation that delivers what you need today, but also preserves your right to choose and have that flexibility that you'll need tomorrow, with a whole ecosystem built around it, with work that's going on in innovation in the upstream communities that is driving then how those communities interact through standards and integration and API management, and then how that gets deployed through the partnerships, through the public clouds, through multiple public clouds, and how that will interact back with what you have deployed back at the data center. This world of hybrid cloud and being able to use traditional and deploy traditional workloads with your cloud native workloads and adapt and adjust as you go, that's what's critical. And laying that foundation now for being able to deploy that cloud of the future that the Department of Defense or our commercial customers need going forward. It's all about flexibility. So it's that combination of flexibility with the confidence that Hillary talked about.
And that idea of open source, open principles raises a question, kind of a detail in my mind, but I thought, Stephanie, you might be a good one to ask this. And the open source culture is that everyone can contribute to it. And we have repositories of services and so forth. Yet when people talk about commercial clouds and the various competitors, they talk about the specific services that those cloud providers offer. Is it possible in this multi-cloud environment, we'll get more into that in the next question, but is it possible in the world of cloud as we know it, which is multiple, that someone could contribute a open source new service that's not offered by any of the clouds, and yet in that manner it could be offered through those clouds, but contributed on an open source basis? Does that happen? Is that possible?
I mean, we see the root of innovation. Everything that we see gets done in upstream and upstream communities, and the breadth of the people contributing is exactly the beauty and the magic of how it's done. Then as you see that start to integrate with other capabilities being done in other open source projects, it starts to deploy and come back to a solution. And that's where we see adoption by folks like public clouds in order to turn that into a service. So to me, it's really quite amazing to see how all of the different innovations being done in the upstream communities combine and interoperate to deploy a solution. And then when you look at how a customer wants to consume that, they can, once it becomes sort of a solution deployment, and if they want to consume that as a service, that's where we see the public cloud stepping in order to deploy that. And then it feeds into this whole maximum variability and possible consumptions that you want to do in a hybrid cloud. That to me is the real goal of hybrid cloud. It's being able to build an application, having optimal flexibility for how I want to do that, whether it's as a service, on-prem, off-prem, multiple public clouds. That's the nirvana of what a hybrid cloud can provide. And open source is where the innovation to do that is happening.
All right, let's get more into that idea of multi-cloud approach, the hybrid approach, because if you look at DoD, it's a pretty complex enterprise. And sometimes the left hand doesn't know what the right hand is doing there. And they're not having great luck with a single cloud of record approach. And we all know where that story's been going. But the reality is they are using multiple clouds, as most federal agencies are. So should they continue that way, and what can they get? Maybe build on what Stephanie said already, Hillary, and the idea of the benefits of, even though there's complexity and brokering required and all of this, that there is benefits to having multiple clouds.
Yeah, it's interesting. I think that the industry as a whole within the topic of cloud and cloud technology is having a much more mature conversation now about really what defines a cloud. And I sometimes sort of, make a cheeky statement to some of my colleagues, wait, what was a cloud again, right? Define that for me. And I don't mean it's not that we don't have cloud products and have a cloud and have cloud strategies and platforms and things like that, but I think it's really important in this conversation to kind of ground in what are those fundamental principles of what makes something cloud, what were we trying to get out of it, what is the DoD looking to achieve, and what can be offered by cloud technologies. And I think if we strip things down, there are core value propositions that center around the open source, which Stephanie was talking about, Linux, Kubernetes, fundamental places that can be secured, that can be deployed in a consistent way across multiple environments. Those on the flip side also then give the DoD the ability to move faster, right? We're trying to standardize things when we talk about clouds so that you can create content, check content, deploy automation, deploy and create new things more quickly. And then there's the notion of services and as a service, as you brought up, where capabilities are stood up and ready to go at the click of a button. The cloud provider is managing those things for you. And that also facilitates the agility and the speed and the rate and pace at which the DoD's various elements and parts can move in responding to new things happening in the world and responding to changes in mission, in removing cost out of existing infrastructure and deployments. And so cloud really has all of these properties about it. And so that's why I kind of say, wait, what was cloud? What are we trying to accomplish? And therefore, how do we architect? And to me, the conversation of 2021 is your cloud architecture. not just which cloud are you using, right? And when I say cloud architecture, it's about taking a step back and saying, okay, we had use of a number of different environments. Moving forward, how far does the cloud need to go? Actually, in most cases, it needs to go all the way out to the edge, right? You want to do computing in that modern, fresh cloud way in all the places you need to deploy things, in all the places that you have mission, in all the places that you have people, et cetera, office buildings, whatever it is, right? And so the cloud extending out into the edge, the cloud having a robust deployment location as a set of public cloud estates is also really important, but kind of defining where the cloud is, all the places it must live, what the core objectives are on cost reduction and velocity. And that leads then to a conversation about platform and what is the cloud platform that you can deploy across those many environments. Red Hat has the OpenShift platform, which can be consumed in public cloud as a service, to your point, and deployed on the edge and managed on the edge as well, even as a service now. And so from the perspective of having a platform decision, there's the platform conversation, which is the architecture conversation that defines sort of what the cloud is, and then where you begin to consume it, how you begin to consume it, and when you are in particular locations, what are the differentiating features of those different cloud environments? The edge will usually kind of be smaller, you're a little bit more lightweight, right? Doing some analytics, strategically or things like that. But maybe not the huge, massive, computations that need to be done. Or when you're doing particularly sensitive things around particularly sensitive data, maybe choose a public cloud deployment option, that is focused on data protection and crypto and secure data storage, and has appropriate controls and standards and things like that. So that if you can have a platform and have a consistent architecture, you have more people and developers working in a consistent way to achieve those cloud outcomes of cost reduction and velocity, but you still make kind of strategic deployment locations appropriate to each application. Maybe it runs on the edge, maybe it runs in a secure data center, maybe it runs in a public cloud location that's hardened in certain ways, maybe it runs on commercial cloud.
Yeah, so a lot to take in there. And I guess maybe, Stephanie, we should coin a new phrase here to go along with DevOps. Maybe agencies need a cloud ops end to handle and assign all of the capabilities they're developing in their DevOps.
I mean, there's the beauty of it, Tom, is that there's so many choices that can be made now with all the innovation that's happening in technology. The challenge is, how do you make those choices in a way that delivers you value and return on that? And you mentioned earlier, it becomes very complex when the thoughts around modernization and use cases, they're not decided in a centralized way, right? It's a decentralized decision model, and how that happens. That by itself demands that you're able to do heterogeneous deployments. You're able to make those decisions at the right time with the right assessments of how much is it going to cost? What's the risk associated with it? Do I want to deploy it on-prem or off-prem? And all of that leads to your cloud strategy has to be hybrid, has to be agile, has to be able to make decisions as you go. And Hillary talked really well about the importance of the platform in that. And that's where we're focused at Red Hat. It's about how do we help deliver a language that gets spoken across all of that. That's where we believe Linux is the language that's spoken across all public clouds in AI and machine learning. We have Red Hat Enterprise Linux. When you want to deploy that in a Kubernetes environment and deploy containerized, it's built with OpenShift. But our internal development model is that the Linux that's included in OpenShift is RHEL-based to provide that stability of language. Having that base foundation where you can build once and deploy many times, whether that's out at the edge or whether that's back in the data center or on multiple clouds, that's the flexibility that having that language and that foundation, that platform really makes a difference.
And of course, all of this activity has to take place in a secure manner. And security is one of those targets that's also moving all the time. So let's comment on what are the best practices nowadays for security in the cloud and all you do there.
Well, I'll maybe start kind of at the level of the public cloud conversation. Security is always something where if we take some simple analogies of what happens in a skyscraper or even a hotel, There's video cameras outside, there's someone at the front desk, there's some sort of authorization, right, in terms of, badges or key cards or things like that. But yet you may still have granularities of security. Even in a hotel room, you may choose to protect particularly sensitive data, so to say, inside that vault, that's in your hotel room, or in an office building. You may have certain areas that are, again, walled off and have additional layers of security. So security is always this kind of decision process, around, what are additional layers of protection that we're going to provide. And I think, one of our strongest focuses in public cloud deployments has been in what is termed in computer science community confidential computing. It's kind of a new term and word that's starting to bubble up and get a little bit more, I guess, awareness, in certain communities. But fundamentally, it's about data privacy, and it's about having authority over a workload, complete privacy and authority over workload, even when it's running in a multi-tenant environment like a cloud. Confidential computing is really key to, things that the DoD and other agencies should be looking at in their consideration, for cloud. And we leverage confidential computing, this sort of highest form of security, that, ability to store your information and your code and everything else like that. Also, despite all the layers of security in the cloud, also store it inside of that vault in the hotel room. And to have that additional layer of security is appropriate for, particularly sensitive data. And we leverage confidential computing technologies to stand up services on the cloud that provide very strong assurances around key management and data privacy, so that, for example, our cloud operators are unable to get access to the keys to protect data, even if, asked, et cetera, right? So it provides just the most stringent, level, and it goes, sort of in some sense above and beyond just trusting the cloud and assuring certain standards and compliance are in place, which of course are, into that assurance that, even against any sort of insider threat, et cetera, that there are additional mechanisms. And I think, this is an exciting time, for us, in technology, because things like confidential computing are finally, after decades, to be honest, of hope, maturing to the place where they can actually be deployed. And that's the beauty of cloud as well, because we can run and operate these capabilities and provide that higher level of function, like data protection. You don't have to figure it all out yourself, how to use the root of the secure enclave and the operating system and the custom hardware, right? We just provide it to you as a capability to protect your data. And that's what we can do when we're operating a cloud, is to bring together technologies and hand them off to customers in an API-driven click of a button sort of a way. But I think, that's not to say that there isn't, a ton to be done as well, and a lot of great innovation that's happened in security down at, the fundamental platform layer. So I don't know, Stephanie, if you want to jump in as well at that level.
I mean, we view security as almost like a lifestyle. You'll have to figure out how you address security on all different levels. So all the way down to the operating system, where we have SE Linux incorporated into RHEL and therefore incorporated into OpenShift. And touching on the cloud aspect that Hillary talked about, one of the key things, and certainly the FedRAMP program is an example of this, there are varying levels of security that are required depending on the mission of the application that you're trying to run, dependent upon the data that you're trying to do. Part of the beauty of hybrid cloud is being able to pick and choose where you deploy those applications, on which level of security that you need for that application, for that data, and having that flexibility. And that sort of lifestyle, or addressing security at multiple layers, that even moves out to the layer of things like automation, being able to automate and deploy applications repeatably, getting out the manual processes, which can be prone to error, right? Automating can help provide a more stable and consistent way of deploying, and that enhances security as well. So it really is a whole lifestyle to adopt to security, but being able to pick and choose the cloud for the application that you need, and deploy those capabilities that Hillary talked about so well, having that flexibility is part of the beauty of the hybrid cloud.
And of course, all of this is aimed at the basic reason for computing, and that is to run applications so that people can get some mission or piece of work done. And this is the challenge that every federal agency is facing, whether to develop brand new logic and applications for cloud deployment, Everyone knows you can't just take the legacy applications with the legacy code and upload it to the cloud, but maybe you can virtualize it, containerize it, emulate it. There's a million ways to skin the cat. So, what's the best approach for DoD agencies to think about what they do next with applications? Because business cannot be interrupted. Let's put it that way. Hillary, you want to try that one first?
Sure. It's a journey that we are on with enterprise clients around the world, and working with our federal clients, I think, has a lot of, I guess, parallels to what we see happening globally. Within the DoD, there's a wide range, as you said before, of different, types of infrastructure, different types of systems, and a wide range of sort of latency sensitivity with regard to certain missions, a range of, degree of sensitivity to analytics or data, to, in other cases, things that are much more sort of what we would call like a system of record, high transactional throughput kind of a workload. I think when approaching an estate, so to say, and so many different elements of the DoD that have such an urgency, around modernization and such, we have to approach everything systemically from the perspective of planning for resiliency, planning for continuity, planning for security and compliance, and then planning for the transformation of the workload itself. We take a very complex process like that and break it down into, planning and different factors, analysis of particular applications, and we define landing zones. We define, target configurations of the cloud, and as Stephanie was saying, defining sort of what needs to run where based on data sensitivity, workload type, the need to access data at the edge, et cetera. So we work sort of on an application basis, or sort of an estate basis, to do that planning and ensure that things are targeted toward cost and time to new deployment objectives. But it is so critical, as you said, with something like the DoD's incredible mission, for all of that to be done in the context of the resiliency, continuity, and security and compliance planning. Because we've found that when those things are planned in upfront and not, let's plan to move to the cloud and then plan those things, we can significantly reduce the cost. Because as Stephanie articulated so well, if you plan in things like security and compliance to be implemented via automation, those can actually be part of the cost savings that's achieved in moving to cloud and moving to cloud-based deployments. So I think there's tremendous opportunity, even though it has to be done through a specific lens to enable a successful migration to cloud.
And Stephanie, maybe given the wide footprint that OpenShift has on the commercial side, maybe give us a couple of case histories of how commercial clients have approached the cloud movement, the cloud adoption, especially when it comes to applications and that decision tree. Do we retire and recode, refactor, whatever the case might be?
Sure. And I think, one of the key things in that whole decision tree is it does come down to application decision by decision for each application, and assessing what are the risks associated, what is the data. So it is very custom. So as Hillary talked about, going through that process can early on, and planning that way can really help eliminate costs down the road if you prepare for that from day one. One example that comes to mind is we worked with a very large airline, and they have as you can imagine, a ton of data that they are sitting on, and they were looking at, we're losing tens of millions every year to delayed flights, missed flights. How do we use that data to do a better job in our planning? And the board challenged them with 100 days to figure out how they could get better in leveraging their knowledge. Essentially, and I think that's like the DoD, they have a ton of data. How do you extract that knowledge and the actionable learning you can get from that data? So what they did was they did deploy using OpenShift. And what they found was they could deploy very quickly. They could build, deploy, and run apps on OpenShift based upon AI, machine learning, pulling and extracting that out, being able to quickly do turnaround time in an agile way. They were able to deploy on OpenShift a whole bunch of applications, test, use what worked, not use what didn't work. It's all about that agility, but having that base platform, using OpenShift built on Linux that they knew, that's what allowed them to do it. So coming into how we approach leveraging OpenShift and examples like this, where it is about speed of deploying your applications, because as you said, Tom, it is about applications and getting value from applications, which Hillary knows, right? I come from the hardware world, which took me a while to adapt to, because
Sure.
I was very much like, it all runs on hardware. But it's the combination of the two. And how do you pick and choose and marry those applications with the right hardware, with the right deployment mechanism that you want? And pulling it all together is where you can get real value. And it was a great story working with this large airline, and it's all about extracting the information from the data.
All right. You have both given us a tremendous amount to think about. We've been hearing from Stephanie Chiris. She's the Senior Vice President and General Manager for Red Hat Enterprise Linux. And from Hillary Hunter. She's the Vice President and Chief Technology Officer for IBM Cloud. And I'm Tom Temin. You've been listening to Federal News Network. Let me send you all back now to the main studio for more of the DoD Cloud Exchange.